In question 9, the equation of a circle is x squared plus y squared plus 6x minus 2y minus 26 equals to 0. We have to first find the coordinates of the circle, center of the circle and the radius, and then find the coordinates of the lowest point on the circle. Now, the general equation for a circle is given by x minus a whole squared plus y minus b whole squared equals to r squared. So to find the center and the radius, a comma b is this coordinates for the center and r is the radius. So we'll expand this and compare it with the equation to find the value of a, b, and r. Now expanding this, we get x squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equals to r squared. Rearranging this to write it as the equation above, we'll write it as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared, and we'll bring the r squared on the right left hand side and put it equals to 0. Now the coefficient of x in this term is minus 2a, and in the original equation that was plus 6. So a will be equals to 6 divided by minus 2, which is minus 3. And the coefficient of y over here is minus 2b. So this will be equals to minus 2b will be equals to minus 2 over here. So the value of b will be positive 1. Now to find the value of r, this will be a squared plus b squared minus r squared, and that will be equal to the constant, which is a minus 26. So we have the value of a and the value of b. So this will be minus 3 squared plus 1 squared minus r squared equals to minus 26. To find r, we'll make it positive and take it on the right hand side. So this will be 9 plus 1, and this will become a plus 26 equals to r squared. So r squared is 36, and the value of r will be equals to 6. So now we have the coordinates of the center. So that is minus 3 comma 1, and the radius is equals to 6. Now we also have to find the coordinates of the lowest point on the circle. Now to understand this, let's try and make a circle first over here. And the center is minus 3 comma 1. So let's say this will be the center of the circle. Now as the radius is 6, it means it will be 6 units below this. The lowest point will be 6 units below this point. So if this value was 1, it will decrease by 6, which will become a minus 5, and the x value will remain the same. So the lowest point on the circle will have a coordinate minus 3 and minus 5. In part B, we have to find the set of values of the constant k for which the line with the equation y equals to kx minus 5 intersects the circle at two distinct points. So we'll be solving the equation simultaneously, the equation of the circle and the equation of this line. And as we have an unknown constant, we will apply the discriminant b squared minus 4ac. And as the intersection is at two distinct points, we'll put it equals to 0. So first writing the equation of the circle, the center point was minus 3 and 1. So we'll write it as x plus 3 whole squared plus y minus 1 whole squared, and that will be equals to 36. Now we'll replace y over here with kx minus 5. So we'll first write it as x plus 3 whole squared plus kx minus 5. So this will become kx minus 5 minus 1 whole squared equals to 36. We'll simplify the bracket over in kx minus 5 minus 1, which will make it kx minus 6 whole squared equals to 36. Now expanding both of the brackets, we'll get x squared plus 6x plus 9. And over here, it will become k square x squared minus 2ab. So that will be minus 12kx plus 36 is equals to 36. So when we bring this 36 on this side, it will cancel out. So 36 will cancel out. We can now rearrange our equation and put the x squared terms together. So this will be x squared plus k square x squared plus 6x, and the other x term was minus 12kx plus 9 equals to 0. So taking x squared common, this will become 1 plus k squared, and taking x common from over here, this will become 6 minus 12k, and this is a plus 9. So the value of a is 1 plus k squared, the coefficient of x squared. the value of b, which is the coefficient of x, is 6 minus 12k, and c will be equals to 9. Now, putting it in the formula b squared minus 4ac greater than 0, we will get 6 minus 12k whole squared minus 4 times a, which is 1 plus k squared, times 9, and it is greater than 0. Expanding 6 minus 12k whole squared, this will become a 36 minus 2ab. So 2 times 6 is 12, and 12 times 12 is 144. So this will be 144k plus 12k squared will be plus 144k squared. And then minus 4 times 1 times 9 will be a minus 36. And minus 4 times k squared into 9 will become a minus 36k squared greater than 0. Now simplifying this, 36 and 36 will cancel out. 144k squared minus 36k squared is 108k squared minus 144k, and we'll put it equals to greater than 0. So taking, let's say we take 4k common from over here, this will become, so 108 divided by 4 is 27k, and 144 divided by 4 will become 36 greater than 0. So one of the values of k will be 4k equals to 0. So k will be, one of the values of k is 0, and 27k minus 36. So if we find the value of k in this case, that will be equals to 36 upon 27, which is 4 upon 3. Now it is important to know how to give the correct inequality sign. So the two values of k that we got are 4 upon 3 and 0. As the value is greater than 0, it means we are looking for values of x that for which the whole curve will be greater than 0. We can see that if we move backwards from the point 0, x equals to 0, the value will be greater than 0. So we'll give x is less than 0, and moving forward from 4 upon 3, the value will be greater than 0. So x has to be greater than 4 upon 3 for b squared minus 4ac to be greater than 0.